All right, hi everybody. So, thank you for joining this live stream. So there's a lot of channel updates to go over first, and then I have some stories. So, first of all, hit 1,000 subscribers finally, so thank you for that. And then, so we'll talk about that. There are a lot of updates that will only happen. So, the YouTube has like the YouTube Partner Program. I can't join that until I get 1,000 or 4,000 watch. I think it's 3,000 watch hours now as well. So that still needs to happen. I'm going to put links to playlists in this description. I'm also going to find out how to make clips of the live streams if I can do that, because these are going to be probably longer. So we'll see about that, but that's what's happening with that actually. None of these are working properly. There we go. Okay. So we'll see what happens with all of that. And so that's going to come in the future. And then I'll also talk about future projects and more. So it's really nice when like nothing is working on this live stream. Okay. So apparently you can only have like a certain amount of images up at a time. It's like I knew you could have like, oh, I think you can only have like 40 pictures all loaded, but you can only have like certain amounts of pictures visible. So anyway, so yeah, so that's what's happening with that, and I'll talk about future projects as well. But first, let's see. Actually, I am going to go. I'm going to see if I can get. Here we go. I did not have the microphone. My microphone. So now I'm going to see if I can get this thing to work. Okay, so there is no microphone there. So that's nice. Okay, never mind. I don't know where it is. So we're just going to have to go without that for now. So and then I'm going to talk about future projects later on in this video as well. But let's start with, if I can get any of these to load properly. Looking at the Vera Rubin Telescope, not that one. Well, really, we'll just talk about Vera Rubin first, and then I'm going to finally get this. Oh, there's more. Why is there multiple? Okay, I'll use the bigger one. And then the last thing, this one, right? There we go. Okay, so yay. It's so fun when you just have like so many pictures. So we'll talk about the Vera Rubin Telescope. These are all of the chapters, the different things that we're going to talk about. So the Vera Rubin Telescope, Vera Rubin, who she was, the telescope itself, then how they're using AI, the observations, some of the observations it's already made. We'll talk about dark matter, dark energy, cataloging the solar system, the search for Planet 9, that hypothetical ninth planet, right? And then we'll talk about whether or not we're in a black hole. So, like the universe is in a black hole. There's growing evidence for that. I'm going to talk about all that as well. Just touch on it because there's growing evidence, nothing like particularly definitive yet. And who knows if we'll really ever know? We probably will never really know. We'll just have evidence, like know for certain. We'll just have evidence one way or the other, and it seems like maybe we are in a black hole. So let's talk about the Vera Rubin Telescope. So, oh, and then there's actually, I realize there's more that we're going to talk about here too. We're going to talk about, in the future projects, I'll touch on the Artemis program as well. So, okay, I think I just have to get it again. So, actually, no, I do have it. I can load it, I think, hopefully. Let's just try loading it again. There we go. So this is Vera Rubin. So we'll talk about Vera Rubin if I can do this without covering up all the chapter time or the chapters. So that's Vera Rubin. She was really she found like the first big evidence for dark matter and dark energy. And so that's how she eventually got this telescope named after her. She died. Let me see. I can find it. Yeah, she was born July 23rd, 1928. She died in 2016 at 88. And this telescope is now named after her because she was an incredibly famous astronomer. So, and also she studied a lot about just galaxies, dark matter, and dark energy, and really about the rotation of the universe and interactions of objects in the universe. She found evidence for the existence of dark matter by studying the rotational curves of galaxies. Her work showed that stars at the edge of galaxies were moving much faster than they should be based on the visible matter. So that's how she came up. That was this evidence for some other form of matter that we couldn't see. It indicated a large amount of unseen mass, now known, or we call it at least, dark matter because, again, we can't see it. We just have evidence of it. It was exerting this influence. So there was the galaxy rotation curves and these discrepancies. So Rubin and her colleague Kent Ford, who we're also going to talk about later on in this stream, used a spectrometer to measure the speeds of stars in different parts of spiral galaxies, and they found that they were going too fast. So they found that the stars in the outer edges of the galaxies were moving at the same speed as those closer to the center, which they thought that it was unexpected. So they should have been moving slower, but they were moving at the same speed, so they were moving too fast. This discrepancy led her to conclude that there must be a significant amount of unseen mass, which she termed dark matter, which exerted a gravitational force to hold the galaxies together, keep the outer stars moving at their observed speeds. So her work provided strong evidence for the existence of dark matter, which was a concept that had been previously proposed but not widely accepted. So her observations, along with others, helped to solidify the understanding that dark matter actually makes up a majority of the universe's mass, which I have. This actually works. Gonna cycle through all of the images again. This one. So this is an image of. If I can actually. There we go. So this is an image of all of just the distribution of matter, right? So there's 27% dark matter, we believe. We believe there's 68% dark energy and only 5% visible matter. So that means that 95% of our universe is invisible with the technology that we have today. So that's probably a lot of the reason why we don't really know a lot about our universe. It's the two most unexplored regions of our universe is the universe outside of Earth and like the deep sea. So that's really why it's just those technological barriers. It's very, very hard to explore those areas. So that was what she did, and she got this telescope named after her. So now let's talk about this telescope. That's not what I wanted. So these are some images. We'll talk about that one specifically in a moment. I'm trying to find the one with the actual telescope. All right, so that's an image of the telescope, just a big outer image. And I'm going to see, I actually, just realized I have not been checking the chat. So let's see this. Oh, you know what? Can I? That's strange. It doesn't show up there. Okay. There we go. Okay, so nice. Oh, okay. So that's fine. Then So let's look at this telescope. So this is the Vera Rubin Telescope. It's $1 billion telescope. It started construction in, I believe it was 2016. Did the 2015, technically, it started construction and it's now operational. So there are a lot of different discoveries that it's hoping to make, that these astronomers are hoping to make with it, rather. And so let's go over those. So, and then this is a look kind of on the inside. This is a look at the mirrors. So that's very fascinating. That's a cool look at those. So it's going to look at dark matter, dark energy. It's going to catalog the solar system. We're going to talk about how this could impact the search for Planet 9, which is a hypothetical ninth planet, which they've also supposedly found candidates for, but it's not just whether or not there's a ninth planet, it's whether or not this supposed ninth planet is actually the thing that's causing the what we're seeing at like the edge of like the Kuiper Belt, whether a ninth planet is responsible for that at all. That is also a cause of discussion among astronomers. So let's look at this. So one of the things that it's going to do is it's going to catalog the solar system. So it's just going to make a big catalog of all of the objects in our solar system. So it has discovered so many new small celestial bodies like asteroids and comets, and it's going to provide detailed information about their orbits, colors, and variability. Also going to study, the solar system, now, the 8 planets and all of that. So, and it's going to significantly improve our ability to detect and characterize potentially hazardous asteroids. So let's talk about just the Vera Rubin Telescope in more detail, how it's going to do all of this. So it has some just incredible technology in there, some really advanced computers, and it uses AI and all of that, large digital cameras. We're going to talk about all that. And the data will be processed by algorithms which will search for moving objects and generate these alerts. So that's, where all the AI comes in. So the Vera Rubin Telescope, it's going to scan the sky it's over like periods of 3 nights, portions of the sky. And that's how it's going to come up with that data. So lastly, a big reason that astronomers are really excited about this telescope is maybe it could find Planet Nine if it's really so not just find it, but either find it or rule it out. Because again, there's still a lot of discussion about whether or not this actually exists. So I've talked to some astronomers who are like, there are other things that could explain this, and there's a lot of belief that, oh, this could be explained, what's happening, by stuff we already know. So, and there's still that discussion out there, but they're saying this telescope could help find it. So far, the only. Actually, this is not quite right, but let's go through this article. This is an article by NPR. So there's the only real evidence that we have is oddities in the orbits of small Pluto-like bodies. So no one's actually spotted Planet 9 because it's too far away. So it orbits something like 20 times further than Neptune and Pluto, the outer planet. So it's so far away. It would take many times the time of Pluto to orbit the sun. So it would take between 10 and 20,000 years potentially to orbit the sun. Pluto, for reference, takes like 240 years. 248 years, yeah. So it would take like at least 45 sometimes to orbit the sun as Pluto. So it's so much further away, so many times what even the furthest planet as we know it would take. So it's going to be incredibly hard to find. It would be groundbreaking if we do discover it. And the last thing that we're going to cover on this topic is they have candidates. So they have identified candidates by analyzing data from two decommissioned satellites, IRAS from 1983 and Akari from 2006. It's not a direct observation, but the object's movement between the two data sets, which spans 23 years, suggests it's a distant, slow-moving object. So, which is consistent with all this data. So let's look at this. So this was a paper published back in late April. So astronomers from Taiwan, Japan, and Australia claim they have found hints of the so-called Planet 9 in archival images of the night sky, archived images of the night sky. So there is evidence, again, from these satellites, and they have some candidates. And these would potentially explain the orbits of the objects beyond Neptune, but again, we don't have any sort of direct observation. So we do need better technology to be able to do that. There's the James Webb Space Telescope, there's this telescope. So, this definitely is something that I will cover in the future as we'll see how this situation develops. So, now let's talk about and also I guess the very last thing I wanted to touch on, actually, now. So, now let's talk about this comet. So, where is it? Okay, yeah, so that's the comet. This is C 2014 UN 271 Bernardelli-Bernstein. So this is the largest comet ever discovered, and astronomers have found some really groundbreaking things out about it. So they already knew it was the largest comet ever discovered. It's going to come closest to Earth, which I believe is only like Saturn, the orbit of Saturn, so not particularly close, but it's so massive that it's still going to get fairly bright. And it's the largest comet ever discovered, and they've discovered some really groundbreaking things about it. So the So it's 31 miles. Its radius is a little more, ever so slightly more than 31 miles. So it's like 62 miles in diameter, really big for a comet. And it does seem to have a really high intrinsic brightness. So what they discovered about it very recently in the past week was that there were gases already coming out of it. So even this far out from the sun, it was already chemically active, which is a really big sign of a really bright, active comet. That it's this active, this far out from the sun. Now, it's not going to come closest to Earth until I believe 2031. Yes, April 5th, 2031. So it will pass at a distance of 10.1 AU, which is approximately 1.5 billion kilometers. So, or 0.94 billion miles, so 940 million miles. So it won't get particularly close to Earth, but it's already so intrinsically bright and it's so big, it's so large that it will become fairly bright. Again, this is an image of that. Let me just make this bigger so you can see. So this is all of the comets. Or all of the largest comets. You can see it's very big. So that was There we go. So that was that comet. So now let's talk about future projects. So I still need the watch hours for the YouTube partner program. So I'm going to be doing, I mean, obviously there's videos continuously. I'm going to be doing, hopefully, maybe a stream or so a week, and then couple videos, maybe 2 to 3 videos a week, depending on my schedule. I'll just say probably, well, let's say 1 to 2 videos a week. And I am working on my review of the Celestial Nexar ADC telescope. It has been really hard to record, but also I'm trying to make it great. And then I have been waiting a little bit just because YouTube doesn't really start to promote content from certain channels until they get over 1,000 subscribers, and I really am trying to get that video to do well. I don't know if it's like monetization. I think it probably has something to do with that. Probably just they don't know if you like have enough visibility to become bigger and help them, because the thing about the YouTube Partner Program also is they take 30% of the revenue. So you only get 70% of the revenue. So they're literally making money off of you, which I guess is kind of like taxes, but of a kind. Anyway, so that's what's happening with that. That is coming though, and it's June 28th. Let's just say July. It will come next month. But as for other future projects, let's talk about the Artemis program. It's so nice when things don't work. I love that. That's not what I wanted. Okay. I guess I have to reload it. I don't know. Maybe it's like... So, yeah, I don't... It's very strange. Like, sometimes they load, sometimes they do not properly. So that's a picture of the Artemis 2 crew. That is a picture of, like, the mission path. What do you mean? I don't know what it's doing. Okay, apparently I cannot use image 3, so let's say... Why... Do I have too many images? Maybe? Okay, let's... Not that. Okay, let's try this again. So that is the crew and the mission path for Artemis 2. So that's the mission that's supposed to launch. Let's just talk about this then. So that's supposed to launch in April of 2026, and I will hopefully be going out to the Kennedy Space Center to see that, and I will be covering it on this channel. I'll be covering like the lead up, any developments, delays, any milestones with the spacecraft or the crew, all of that. Any of those developments. I'm also going to do a video on the NASA budget. The Space Launch System, let's see if that, okay. So I don't know if it's like it covers it up or something, but wow, this is ridiculous. Okay. So now that I have, so that's Artemis 2, that's the flight path. So then, okay. So that's those two. We'll see if I'm able to get anything else. There we go. So that, okay, finally, in a way. So that is this is just the flight path of, so basically what they're going to do, they're going to launch, they're going to orbit the moon and the Earth, and then they will come back. They're not going to land on the moon yet, they're going to land on the moon on Artemis 3. So again, I'm going to be covering Artemis 2. I'll do videos, live streams, hopefully go out there and do other videos. Also, hopefully videos of the Kennedy Space Center. If I go there, I'll do tour videos, like what to know before you go there and all of that. So definitely subscribe for that if that is something you are interested in. And so this is that's the NASA Space Launch System right there. And oh, that's what was going on with that. So there we go. And so that's that Space Launch System. So who is going to be flying on this mission? So there are 4 astronauts. So Reed Wiseman is the commander. Victor Glover is the pilot. Christina Koch is the mission specialist. The 2 mission specialists, so Christina Koch and Jeremy Hansen, are the mission specialists. So that's the crew for Artemis 2. So yeah, and so I will be covering that whenever that happens. It's supposed to happen in April of next year. So we'll see, and hopefully it does. And they're also phasing out the Space Launch System. So it will launch Artemis 2, so these astronauts. Then it will launch Artemis 3 in, hopefully they're saying 2027. and that's going to be its last flight. And then beyond that, the Artemis program should use the SpaceX Starship or other commercial rockets, but probably the SpaceX Starship because it's the only one that's capable enough to replace the Space Launch System. So yeah, so that's the live stream and future projects. So definitely subscribe for that. And I'm glad we got to this milestone, and there will be more coming. So thank you for watching, and I will see you in the next video or live stream, hopefully next week. All right.